Picture the weekly ritual that consumed entire days. Women bent over steaming wash tubs, scrubbing clothes against rough washboards until their knuckles bled. The endless cycle of soaking, boiling, wringing, and hanging that left hands raw and backs aching. This was laundry before the machine. What if someone could transform this ancient burden into something as simple as pressing a button? In 1900, a seamstress named Alva Fisher watched her mother's hands crack and bleed from lye soap. She witnessed how wash day aged women prematurely and stole time from everything that mattered. Her quiet determination would spark a revolution that reached into every home. From her first workshop experiments, Fisher's machines would shake violently across floors and shoot sparks from faulty electrical connections, failures that taught harsh lessons about the gap between vision and mechanical reality. Yet she persisted, studying water currents in riverbeds and the rhythmic motions of skilled laundresses. She translated nature's wisdom into gears and perforated drums. When patent number 966,677 arrived in 1908, it represented more than technical achievement. It embodied a complete reimagining of domestic life. Fisher's gentle agitation system and waterproof electrical enclosure would free millions from Monday martyrdom. Though she'd face investors who wanted her name erased and competitors who claimed her innovations were obvious, by 1920, her invention had returned 40 billion hours to American families, hours that became degrees earned, businesses started, and children nurtured. The transformation was so complete that grandmothers and granddaughters seemed to inhabit different centuries. Tonight, as washing machines hum in homes across the world, they sing Fisher's quiet song of liberation. Her story begins with a young woman sketching improvements to household tools, determined that suffering shouldn't be accepted as women's inevitable fate. In 1900, Monday was universally dreaded as wash day, a grueling marathon that began before dawn with hauling water, building fires, and preparing for hours of physical punishment. The ritual consumed entire households, transforming kitchens into steamy laundries where copper boilers bubbled over wood-fired stoves. Washboards stood ready like instruments of torture. Women rose at 4 in the morning to begin heating water, knowing they faced 12 hours of back-breaking labor. Their hands would be raw, their spirits drained. The wealthy hired laundresses, but most families endured this weekly torture themselves. Mothers taught daughters the grim techniques of soap making, water temperature, and the precise motions needed to scrub away stubborn stains. Young girls learned to judge water heat by the pain threshold of their elbows. They mixed lye soap without burning their skin and wrung heavy sheets until their small arms trembled with exhaustion. This knowledge passed down through generations like a burden no one questioned, simply because no alternative existed. Alva Fisher grew up watching her mother's hands crack and bleed from lye soap. She saw how wash day aged women prematurely, consumed precious time that could be spent on family, education, or personal pursuits. She noticed how her mother moved slower each Tuesday, how the skin on her knuckles never quite healed before the next Monday arrived. The sight of those damaged hands stirred something deep within young Alva, not just sympathy, but a determination. Such suffering shouldn't be accepted as women's inevitable fate. Born in 1862, Fisher displayed an early fascination with mechanical solutions to everyday problems. She often sketched improvements to household tools while other girls played with dolls. She'd sit for hours watching her father work, absorbing the logic of levers and gears. She understood intuitively that machines could multiply human effort and eliminate unnecessary toil. Her sketches filled notebooks, a better butter churn here, an improved apple peeler there. Each design revealed a mind that saw inefficiency as a challenge rather than an unchangeable fact. Her father, a carpenter, encouraged her curiosity about how things worked. He taught her to see problems not as permanent fixtures, but as puzzles waiting for the right combination of ingenuity and persistence. He'd bring home broken clocks and simple mechanisms, spreading the pieces across their kitchen table. He'd guide Alva through the process of understanding each component's purpose. Everything built by human hands can be improved by human minds, he'd tell her. Those words echoed through her thoughts as she watched her mother struggle with wash day. Fisher's education was limited by the era's restrictions on women, but she absorbed every mechanical principle she encountered. She studied the emerging field of electrical engineering through borrowed books and careful observation. She haunted the local library, reading texts meant for engineering students. She translated complex mathematical formulas into practical understanding through sheer determination. When the librarian questioned her interest in such masculine subjects, Fisher simply smiled and continued reading. She stored away knowledge like provisions for a long journey. Working as a seamstress, she witnessed firsthand how the textile industry was mechanizing production. Meanwhile, home laundry remained trapped in medieval methods of manual labor and primitive tools. The sewing machines she operated daily demonstrated how mechanical ingenuity could transform tedious handwork into efficient production. Yet when she returned home each evening, she found her neighbors still bent over washboards. They used the same methods their grandmothers had employed decades before. The contrast haunted her. Factories could process thousands of yards of fabric efficiently, yet individual families still struggled with basic cleaning. She'd watch steam-powered looms weave intricate patterns at impossible speeds. Then, she'd return to streets where women hauled water in buckets and scrubbed until their backs gave out. The gap between industrial progress and domestic drudgery seemed to widen each year. It was as if inventors had forgotten that homes needed innovation just as desperately as factories. Fisher began sketching designs for a mechanical washing device. She envisioned a system that could agitate clothes without human muscle power, using the same electrical principles transforming other industries. Her early drawings showed cylinders and paddles, motors and gears. Each iteration refined the basic concept of mechanized agitation. She worked by lamplight after her sewing shifts, translating the exhausting motions of hand washing into mechanical movements. A machine could perform these tirelessly. Her early concepts faced ridicule from neighbors who couldn't imagine trusting their precious garments to a machine. They viewed the idea as both impractical and somehow improper for women to pursue. Clothes need a woman's touch, they'd insist, as if bruised knuckles and aching backs were essential ingredients for cleanliness. Some whispered that Fisher was getting above herself. She should focus on finding a husband instead of tinkering with impossible contraptions. Undeterred, Fisher studied existing attempts at mechanical washing. She examined crude hand-cranked devices that barely improved upon washboards and often damaged clothes more than they helped clean them. She visited county fairs where inventors displayed their labor-saving devices. Most required nearly as much effort as traditional methods while producing inferior results. These machines yanked and twisted fabric, tearing delicate items and failing to remove even basic dirt. She identified the core problem. Previous inventors focused on brute force rather than the gentle, consistent agitation that experienced laundresses knew was essential. They'd built machines that attacked clothes like enemies to be conquered, not understanding that effective washing required finesse, not violence. Fisher spent hours observing skilled laundresses. She noted how they coaxed dirt from fabric through rhythmic movements and careful timing. Fisher's breakthrough insight came from observing how natural water currents cleaned stones in riverbeds, not through violent scrubbing, but through persistent rhythmic motion that gradually loosened and carried away debris. She'd sit by the creek behind her workshop, watching how water flowed around obstacles. She studied how sediment lifted and settled in predictable patterns. Nature had already solved the problem. She just needed to translate that solution into mechanical form. This observation led her to envision a perforated cylinder that could rotate clothes through soapy water. It would create the ideal combination of mechanical action and gentle treatment that hand washing attempted to achieve. The holes would allow water to flow through, while the rotation would lift and drop clothes in a controlled manner. It mimicked the most effective hand washing techniques without the physical strain. It was elegant in its simplicity, yet no one had thought to apply this principle to laundry. She spent months calculating the optimal rotation speed, cylinder size, and water temperature. These needed to replicate the best aspects of hand washing while eliminating the physical strain and time consumption. Her notebooks filled with equations and experiments, testing different speeds on various fabrics. She measured the force needed to remove different types of stains. She approached the problem with scientific rigor, understanding that success required precision, not just good intentions. Fisher's design incorporated an electric motor, a bold choice when most homes lacked reliable electrical service. Many people still viewed electricity with suspicion and fear. She believed that electrical power represented the future. Any truly revolutionary washing machine needed to embrace this new technology, rather than rely on hand cranks or foot pedals. The decision would limit her initial market, but position her invention at the forefront of domestic modernization. The technical challenges seemed overwhelming. Creating a waterproof electrical system, designing a cylinder that wouldn't tear delicate fabrics, developing a mechanism that could handle varying load sizes safely. Each problem spawned a dozen more. How to seal electrical connections against moisture, how to balance the cylinder to prevent violent shaking, how to time the filling and draining cycles. Lesser inventors might have retreated to simpler designs, but Fisher saw each challenge as confirmation. She was attempting something truly revolutionary. Despite these obstacles, Fisher pressed forward. She was driven by the vision of liberating women from laundry's physical demands, giving families precious hours to spend on more meaningful activities than endless scrubbing. She imagined mothers reading to their children instead of soaking their hands in lye. She imagined young women pursuing education instead of spending their Mondays in steam and suds. This wasn't just about building a machine. It was about reimagining how families could structure their lives when freed from laundry's tyranny. As 1907 dawned, Fisher stood on the brink of either triumph or devastating failure. Her workshop filled with components that might revolutionize domestic life, or prove that her neighbors were right to doubt a woman's ability to transform an ancient burden into mechanical ease. Fisher's workshop became a battlefield of metal and wire, each failed prototype teaching harsh lessons about the gap between vision and reality. The first machine shook so violently it walked across the floor. Its unbalanced drum threatened to tear itself apart with every rotation. Water leaked from every seam, pooling beneath the machine in accusatory puddles that reflected her exhausted face as she worked through another sleepless night. The electrical components proved especially troublesome, sparking and smoking whenever moisture found its way past her makeshift seals. One evening, a spectacular short circuit sent blue flames dancing along exposed wires. Fisher had to douse her creation with a bucket of sand she kept nearby for such emergencies. The acrid smell of burnt rubber and singed metal filled the workshop, a bitter perfume of failure that clung to her clothes and hair. Local machinists grew accustomed to Fisher's visits. This determined woman who spoke fluently about gear ratios and torque specifications while sketching modifications on any available surface. Some helped willingly, intrigued by her technical knowledge and precise requirements. Others demanded payment she could barely afford, forcing her to take extra sewing work that left her fingers cramped and her progress slowed to a crawl. The second prototype addressed the violence of the first, incorporating a counterweight system that balanced the drum's rotation. But new problems emerged. Clothes bunched together in sodden masses, refusing to circulate through the water. The washing action, such as it was, affected only the outer layer of fabric while leaving inner portions untouched. Fisher watched through the glass observation port she'd installed, studying how fabrics moved, or failed to move, through each cycle. She began thinking like water itself, imagining its path through the perforated drum, visualizing how soap and mechanical action needed to reach every fiber. The solution came slowly through dozens of small modifications. Baffles welded inside the drum at precise angles. Perforations sized and spaced according to mathematical calculations that filled page after page of her notebooks. Each adjustment brought marginal improvements that accumulated into genuine progress. The breakthrough arrived not in a flash of inspiration, but through methodical observation. Fisher noticed how skilled laundresses created a specific rhythm with their hands, lifting clothes up through the water, then letting them fall in controlled patterns. The motion wasn't random. It followed an ancient choreography perfected through generations of practice. Her machine needed to replicate this dance, transforming human knowledge into mechanical precision. She redesigned the drum's interior with curved baffles that caught clothes at exactly the right moment, lifting them through the water in graceful arcs. before releasing them to fall through the soap solution. The angle of each baffle, the spacing between them, the speed of rotation, every variable demanded careful calibration. Too fast and clothes tangled, too slow and cleaning power diminished. The sweet spot existed within a narrow range that took months to identify. The electrical system remained her greatest challenge and most dangerous adversary. Water and electricity coexisted uneasily, their combination potentially lethal. Fisher studied electrical engineering texts meant for industrial applications, adapting principles of insulation and grounding to her domestic scale. She experimented with rubber gaskets, wax seals, and ceramic insulators, learning through painful trial and error which materials could withstand the constant assault of moisture and vibration. Her hands bore the evidence of this education: small burns from electrical contacts, cuts from sharp metal edges, permanent stains from experimental compounds. Yet each scar represented knowledge gained, another step toward a machine that wouldn't endanger its users. She developed a healthy respect for electricity's power while refusing to let fear prevent progress. Word of her efforts spread through the business community, reaching men who saw opportunity in her struggles. A group of investors arrived at her workshop one autumn afternoon, their polished shoes incongruous against the oil-stained floor. They examined her latest prototype with the calculating eyes of those who measure everything in potential profit. Fisher demonstrated the machine's operation, explaining the technical innovations that set it apart from crude competitors. The investors recognized the machine's commercial potential, but bristled at its creator. A woman inventor complicated their marketing plans, challenging assumptions about mechanical competence and domestic authority. They offered funding contingent on removing Fisher's name from patents and publicity, suggesting a fictional male inventor might prove more palatable to conservative consumers. Fisher's refusal came quietly but firmly. These machines bore her blood and sweat, emerged from her understanding of laundry's brutal demands. To surrender credit would betray not just personal pride, but the principle that women could master complex technical challenges. The investors departed, leaving Fisher to wonder if principle would prove too expensive a luxury. Yet compromise eventually proved necessary. A second group of investors, slightly more progressive, agreed to a partnership that preserved Fisher's name while providing desperately needed capital. They insisted on certain modifications, a more conventional appearance, simplified controls that wouldn't intimidate users, safety features that exceeded anything currently required. Fisher negotiated each change, protecting her core innovations while accepting alterations that improved marketability. The patent application process exposed how thoroughly the legal system doubted women's technical capabilities. Patent examiners questioned every claim, demanding explanations that would never be required from male applicants. Fisher responded with documentation that bordered on excessive: detailed drawings, mathematical proofs, testimonials from machinists confirming her personal involvement in every aspect of development. She spent weeks in the patent office, calmly explaining gear ratios to skeptical clerks, demonstrating her complete understanding of electrical principles and mechanical engineering. Her quiet competence gradually overcame institutional prejudice, though she knew future women inventors would face similar battles. The system changed slowly, one carefully documented victory at a time. Competition loomed as larger manufacturers rushed their own washing machines toward market. Most relied on brute force approaches, powerful motors driving aggressive agitators that attacked clothes like enemies. Fisher tested these competitors, documenting how they shredded delicate fabrics and failed to clean evenly. Their designers had never spent Monday bent over a washboard, never understood the subtle dance between fabric and water that effective cleaning required. Her machine's gentleness became its greatest selling point, though explaining this advantage proved challenging. Consumers accustomed to associating cleaning power with physical effort struggled to believe that Fisher's smooth rotation could outperform violent scrubbing. She developed demonstration techniques, showing how ink stains disappeared without fabric damage, how delicate laces emerged intact from cycles that would have destroyed them in competitors' machines. Testing expanded beyond her workshop as Fisher recruited neighborhood women to evaluate prototypes. Their feedback proved invaluable: complaints about noise levels, suggestions for easier loading procedures, requests for clearer controls. Each critique improved the design, transforming a technically sound machine into one that actual users could operate confidently. The soap problem emerged during these trials. Traditional lye-based soaps created excessive suds in the machine's efficient agitation, overwhelming the washing action and leaving residue on clothes. Fisher worked with soap manufacturers to develop new formulations optimized for mechanical washing. This collaboration produced the first detergents specifically designed for machine use, another innovation that competitors had overlooked. Water quality variations across different regions created additional challenges. Hard water left mineral deposits that accumulated on mechanical components, while soft water required less soap but could leave clothes feeling insufficiently cleaned. Fisher developed water testing procedures and adjustment guidelines, empowering users to optimize their machines for local conditions. Safety obsessed her as production plans advanced. Every potential hazard received multiple safeguards: automatic shutoffs if motors overheated, mechanical interlocks preventing operation with the lid open, grounded electrical systems that directed any leakage safely away from users. She imagined every possible misuse and designed protections against each scenario. The instruction manual grew into a comprehensive guide that respected users' intelligence while assuming no prior mechanical knowledge. Fisher wrote every word herself, explaining not just how to operate the machine, but why each feature existed. Understanding bred confidence, transforming suspicious housewives into enthusiastic advocates for mechanical washing. Quality control standards exceeded anything attempted for household appliances. Fisher personally inspected critical components, rejecting parts that deviated even slightly from specifications. Factory workers initially resented this attention to detail, but gradually recognized that her standards protected both consumers and the company's reputation. A single failed machine could destroy public trust that might take years to rebuild. Production began slowly, each machine assembled with watchmaker precision. Fisher haunted the factory floor, observing every process, suggesting improvements that enhanced efficiency without compromising quality. Workers grew accustomed to her presence, this woman who understood their machines better than most engineers. Her quiet competence earned respect that transcended gender prejudices. The first completed machines represented more than mechanical achievement. They embodied Fisher's vision of domestic liberation through thoughtful engineering. Each unit carried the potential to return countless hours to families, to preserve women's health and expand their opportunities. As crates of finished machines accumulated in the warehouse, Fisher allowed herself a moment of satisfaction before returning to work on improvements for the next generation. The patent examiner held Fisher's document with unusual care, recognizing something different in the precise technical drawings and mathematical calculations that filled page after page. Patent number 966,677, filed on August 9, 1908. Described not just another crude washing device, but a complete reimagining of how mechanical power could transform household labor. The examiner's approval came after months of scrutiny, finally acknowledging that Fisher had achieved what dozens of male inventors had failed to accomplish: a truly practical electric washing machine suitable for home use. The patent's language revealed Fisher's deep understanding of both engineering principles and laundry's actual demands. Her perforated cylinder design wasn't arbitrary, but calculated to create specific water flow patterns. Patterns that lifted dirt from fabric without damaging delicate fibers. The perforations themselves followed a mathematical pattern, sized and spaced to maximize water circulation while preventing small items from escaping the drum. Each hole represented hours of testing, measuring the optimal diameter that balanced cleaning power with fabric protection. The gear reduction system proved equally sophisticated, transforming the electric motor's rapid rotation into the gentle, rhythmic agitation that effective washing required. Fisher had calculated the precise ratios needed to replicate the motion of skilled hands, not the violent thrashing of someone attacking stubborn stains, but the patient, consistent movement that coaxed dirt from fabric through persistence rather than force. The gears meshed silently, their teeth cut to specifications that minimized wear, while maintaining the steady rhythm essential for proper cleaning. Variable speed control distinguished Fisher's design from competitors who offered only full power or nothing. Her system recognized that silk required different treatment than denim, that heavily soiled work clothes needed more aggressive action than lightly worn Sunday dresses. Users could adjust the washing intensity through a simple lever, giving them control that hand washing had always provided, but previous machines had ignored. This flexibility transformed the machine from a one-size-fits-all solution into a versatile tool that adapted to each family's specific needs. The waterproof electrical enclosure represented months of dangerous experimentation, each failure teaching Fisher more about moisture's relentless ability to find weaknesses. Her final design used multiple barriers, rubber gaskets backed by wax seals, ceramic insulators protecting critical connections, drainage channels that directed any infiltrating water away from electrical components. The enclosure wasn't just waterproof but over-engineered, incorporating redundancies that ensured safety even if primary seals failed. Fisher understood that a single electrical accident could destroy public trust in all washing machines, not just her own. The automatic timer emerged from Fisher's observation that overwashing damaged clothes as surely as underwashing left them dirty. Hand washing relied on experience to judge when clothes were clean, but machine users needed mechanical guidance. Her timer used a simple clockwork mechanism, reliable and repairable, that shut off the motor after predetermined intervals. Users could extend the cycle for extra dirty loads or shorten it for delicate items, but the timer prevented the absent-minded overwashing that could reduce favorite garments to tatters. Capacity calculations balanced competing demands, large enough to handle a family's weekly laundry efficiently, small enough to fit in typical homes and operate on residential electrical circuits. Fisher measured average laundry loads, timed washing sessions, and calculated water requirements. Her final design could process what previously required a full day's hand washing in just a few hours of attended operation. The math was elegant. Reduced time multiplied by millions of households equaled centuries of recovered human potential. Temperature control added another layer of sophistication, acknowledging that effective cleaning required more than mechanical action. Hot water helped dissolve grease and activate soap, but excessive heat could shrink wool or fade colors. Fisher's system included a thermometer visible through a glass port, allowing users to monitor and adjust water temperature throughout the cycle. This simple addition prevented countless ruined garments, while optimizing cleaning power for different soil types. The drainage system eliminated one of hand washing's most physically demanding aspects, lifting and pouring heavy tubs of dirty water. Fisher incorporated a pump driven by the same motor that powered the drum, activated by a simple valve that redirected power from washing to draining. The pump could empty a full tub in minutes, sending water directly to household drains without requiring any lifting or carrying. For women with back problems or arthritis, this single feature justified the machine's entire cost. Fisher's instruction manual broke new ground in technical writing, respecting users' intelligence while assuming no mechanical knowledge. She explained not just which buttons to push, but why each step mattered, building understanding that empowered users to optimize their washing routines. The manual's tone remained conversational and encouraging, acknowledging that many users felt intimidated by electrical appliances. Fisher included personal anecdotes from her testing process, sharing failures and discoveries that humanized the machine's development. Troubleshooting sections anticipated common problems with solutions that users could implement independently. Motor won't start. Check these 3 connections in this specific order. Clothes emerging still dirty. Verify water temperature and soap quantity using these simple tests. Each solution included clear illustrations and step-by-step instructions that transformed mysterious mechanical failures into manageable maintenance tasks. Fisher understood that user confidence depended on feeling capable of basic problem solving. The manual's fabric guide revolutionized how families approached laundry, providing specific instructions for materials that hand washing had always treated identically. Silk required cool water and minimal agitation. Wool needed careful temperature control to prevent felting. Cotton could withstand vigorous washing, but benefited from longer soak times. This systematic approach to fabric care extended clothing life while ensuring optimal cleanliness, saving families money while improving their appearance. Early demonstrations at department stores drew crowds of skeptical women who arrived expecting disappointment. Fisher or trained demonstrators would load the machine with visibly soiled items, grass-stained children's clothes, grease-spotted work shirts, delicate lace collars. The 30-minute cycle seemed impossibly short to audiences accustomed to hours of scrubbing. Yet when the lid opened, revealing spotlessly clean garments without a trace of damage, gasps of amazement rippled through the crowd. The efficiency statistics seemed almost fictional, a full load completed in 30 minutes versus 4 hours of hand washing. Yet timing demonstrations confirmed these claims repeatedly. The machine's consistent agitation reached every fiber uniformly, while hand washing often left hidden pockets of dirt in seams or folds. The mechanical action actually achieved superior cleaning, while requiring virtually no physical effort from the operator. Women who had resigned themselves to Monday martyrdom suddenly glimpsed freedom. Soap consumption dropped dramatically with Fisher's machine, as the efficient mechanical action multiplied detergent effectiveness. Hand washing often required multiple soap applications as tired hands lost scrubbing vigor. But the machine maintained optimal agitation throughout the cycle. The precise water circulation carried soap to every fiber, while the controlled temperature kept it actively cleaning rather than simply dissolving. Families found their soap expenses cut nearly in half, while achieving better results. The physical relief was immediate and profound. Women who had suffered chronic back pain from bending over wash tubs stood upright throughout the washing process. Hands previously cracked and bleeding from lye exposure remained soft and undamaged. Elderly women who had gradually surrendered laundry duties to younger relatives could resume caring for their own clothes, restoring independence that age had stolen. The machine didn't just save time, it preserved bodies. Quality testing revealed an unexpected benefit. Clothes lasted longer when machine washed. Hand washing's irregular pressure stretched and distorted fabric, particularly when tired hands grew impatient with stubborn stains. Fisher's consistent mechanical action avoided these stress points, while ensuring even cleaning throughout each garment. Favorite dresses maintained their shape. Expensive fabrics retained their texture. The machine's gentleness actually exceeded what human hands could achieve. The consistency of results transformed laundry from an unpredictable struggle into a reliable process. Monday's outcome no longer depended on the washer's health, mood, or energy level. The machine performed identically whether operated by an experienced housewife or a teenage daughter, democratizing domestic competence. This reliability allowed families to plan their weeks, knowing that laundry would require a specific, manageable time investment. As word spread through demonstrations and early adopter testimonials, orders began overwhelming Fisher's small production facility. Each completed machine represented liberation for another family, another woman freed from Monday's bondage. Yet demand far exceeded supply, forcing difficult decisions about production expansion while maintaining Fisher's exacting quality standards. The waiting lists grew longer, as more families recognized the machine's transformative potential. The patent's approval marked not an ending, but an acceleration. Competitors studied Fisher's design, seeking ways to circumvent her protections while capitalizing on the market she had created. Some produced inferior copies that damaged clothes and endangered users, threatening to destroy public confidence in all washing machines. Fisher found herself defending not just her patents, but the very concept of safe, effective mechanical washing. Legal battles loomed as larger manufacturers challenged Fisher's patents, claiming her innovations were obvious combinations of existing technology. She responded with detailed documentation of her development process, proving that her solutions emerged from systematic experimentation rather than lucky accident. The gear ratios, perforation patterns, and safety systems represented years of careful refinement that competitors had failed to achieve despite greater resources. The machine's success attracted investors who finally recognized Fisher's genius, though some still struggled with her gender. Board meetings became battlegrounds where Fisher defended design decisions against men who had never done laundry, yet felt qualified to suggest improvements. She maintained her quiet authority, letting test results speak louder than arguments. When executives proposed cost-cutting measures that would compromise safety or effectiveness, Fisher simply demonstrated how such changes would destroy the machine's reputation. Production expansion required careful planning to maintain quality, while meeting explosive demand. Fisher personally trained assembly workers, explaining not just how to build the machines, but why each component mattered. She instituted testing procedures that verified every function before shipping, understanding that early machines would shape public perception for years. Workers initially resented such attention to detail, but gradually took pride in building appliances that would transform customers' lives. The social implications of Fisher's success rippled outward in unexpected ways. Churches noticed increased attendance at women's auxiliary meetings, now scheduled for Monday afternoons when laundry no longer consumed the entire day. Schools reported more mothers volunteering for activities previously impossible to support. Community organizations flourished as women discovered energy and time for civic engagement. The washing machine was reshaping society's fabric as surely as it cleaned clothing. Yet success brought new challenges that would test Fisher's vision against market pressures. Competitors prepared aggressive campaigns to capture the market Fisher had created. Larger manufacturers possessed resources that could overwhelm her small company. Patent disputes threatened to consume profits and legal fees. The very success of her innovation attracted forces that could destroy the company she had built through years of solitary effort. As 1909 approached, Fisher stood at a crossroads. That would determine whether her invention would remain a footnote in history or transform domestic life for generations. The machine humming in her workshop represented more than mechanical achievement. It embodied a vision of technology serving human needs rather than corporate profits. The question remained whether that vision could survive. The brutal realities of American business. The first Fisher washing machines reached consumers in 1909, transforming laundry from a dreaded weekly ordeal into a manageable task that freed women to pursue education, careers, and personal interests previously impossible to maintain. Each delivery represented a small revolution, as families unpacked machines that would fundamentally alter their weekly rhythms and expand their horizons beyond the narrow confines of domestic drudgery. Early adopters reported life-changing results that exceeded even Fisher's optimistic projections. Mrs. Sarah Henderson of Chicago wrote to the company, describing how she had enrolled in evening literature classes at the local college, something unthinkable when Mondays meant 12 hours of back-breaking labor. Her neighbor, Margaret Chen, used her recovered time to establish a small seamstress business, taking advantage of skills that wash day had previously left her too exhausted to employ profitably. The ripple effects spread through households like gentle waves. Children noticed their mothers' improved moods on Tuesday mornings, no longer facing women drained by yesterday's ordeal. Husbands found their wives had energy for conversation in the evenings, for walks in the park on weekends. The machine didn't just wash clothes, it washed away the exhaustion that had settled over families like an unwelcome guest. The machine's success sparked a revolution in household management that home economists had only dreamed possible. Families discovered that reducing laundry time created opportunities for improved nutrition, as mothers could spend more time preparing varied meals rather than subsisting on simple fare during wash day. Children received more attention to their studies, their hygiene, their emotional needs. Gardens flourished under newly available care. Homes grew cleaner as energy previously consumed by laundry could address other maintenance tasks. Women's magazines began featuring articles about this new leisure, though the term proved somewhat misleading. The time wasn't idle. It was redirected toward activities that enriched family life. Good Housekeeping published meal planning guides for families adjusting to having Monday available for normal cooking. Ladies' Home Journal ran series on educational activities mothers could pursue with children during hours previously lost to washing. The magazines themselves saw circulation increase as more women found time to read. Community organizations experienced unprecedented growth. Church auxiliaries that had struggled to find meeting times that didn't conflict with wash day suddenly had Monday afternoons available. Literary societies expanded their membership roles. Charitable organizations discovered a workforce of women eager to contribute to social causes, now that domestic duties no longer consumed every available hour. The washing machine was quietly restructuring civil society. The economic impact extended far beyond individual households. Commercial laundries initially feared obsolescence, but discovered new opportunities serving businesses and institutions while residential demand declined. Hotels, hospitals, and restaurants still required industrial-scale washing that Fisher's home machines couldn't handle. Meanwhile, entirely new industries emerged, manufacturing not just machines, but specialized detergents, replacement parts, and maintenance services. Employment patterns shifted as women entered the workforce in unprecedented numbers. Factory positions previously impossible to maintain while managing traditional wash days became viable options. Secretarial schools reported increased enrollment from women who could now commit to regular attendance. Retail establishments found a growing pool of female employees who arrived rested rather than exhausted from yesterday's laundry marathon. Fisher's success inspired other inventors to tackle remaining household drudgery with new determination. If washing could be mechanized, why not other repetitive tasks? The vacuum cleaner evolved from crude hand-pumped devices to efficient electrical models. Refrigeration moved from ice boxes to mechanical cooling. Electric irons replaced their coal-heated predecessors. Each innovation built upon Fisher's demonstration that thoughtful engineering could transform domestic labor. The cumulative effect was extraordinary. Within a single generation, the average time spent on household chores dropped by half. This wasn't just efficiency, it was liberation. Women born in 1890 who spent their youth watching their mothers age prematurely from domestic toil saw their own daughters pursue college degrees and professional careers. The transformation happened so rapidly that grandmothers and granddaughters seemed to inhabit different centuries. The washing machine's popularity accelerated demand for reliable electrical service with an urgency that surprised utility companies. Families who had previously viewed electricity as a luxury for lighting now considered it essential infrastructure. A house without electrical capacity for a washing machine became as undesirable as one without running water. Real estate advertisements began highlighting washing machine-ready electrical systems as selling points. Utility companies responded by expanding residential infrastructure at unprecedented rates. Power lines stretched into suburbs and rural areas where demand had previously been insufficient to justify investment. The washing machine drove electrification more effectively than any government program, as families willingly paid for service that would support their most important appliance. By 1915, electrical contractors reported that washing machine installations comprised their largest source of residential work. The machine's impact on women's health provided compelling medical evidence of technology's benefits. Dr. Elizabeth Morrison conducted a 5-year study comparing health outcomes in neighborhoods with high washing machine adoption versus those still relying on manual methods. Her findings were striking. Reduced incidence of back injuries, decreased arthritis symptoms, fewer chemical burns from lye exposure, and improved overall physical condition among washing machine users. Dermatologists noted dramatic improvements in women's hand health. The chronic cracking, bleeding, and premature aging caused by hot water and harsh soap exposure virtually disappeared among washing machine users. Younger women who had watched their mothers' hands deteriorate found their own remaining smooth and capable. The psychological impact of maintaining attractive, pain-free hands boosted confidence and social participation. Mental health improvements proved equally significant, though harder to quantify. The elimination of Monday dread, that Sunday evening anxiety about tomorrow's ordeal, allowed families to enjoy weekends fully. Women reported better sleep, improved appetites, and decreased irritability. The constant physical exhaustion that had characterized previous generations of mothers lifted like morning fog, revealing energy and optimism that had always existed, but never had space to flourish. The social implications rippled outward in ways Fisher might never have anticipated. Women's suffrage movements found new supporters among those who finally had time and energy for political engagement. Labor organizations discovered that female workers could maintain consistent attendance when domestic duties no longer created Monday absences. Educational institutions reported increased female enrollment at every level from primary school through university. Fisher's invention contributed to changing perceptions of women's capabilities by demonstrating technical competence in a highly visible way. Every successful washing machine installation countered arguments about female mechanical incompetence. Women who operated these complex electrical appliances daily proved capable of understanding and maintaining sophisticated technology. The machine became an inadvertent argument for women's intellectual equality. The washing machine industry grew with stunning rapidity. By 1912, over 30 manufacturers produced variations on Fisher's design, though none matched her original's thoughtful engineering. Competition drove innovation in motors, controls, and safety features, while prices gradually declined through manufacturing efficiencies. What began as an expensive luxury evolved into middle-class necessity within a decade. Patent disputes proliferated as competitors sought to circumvent Fisher's protections. Some produced inferior machines that damaged clothes or posed safety hazards, threatening to undermine public confidence. Fisher found herself not just defending her patents, but educating consumers about the differences between quality machines and dangerous imitations. Her technical articles in women's magazines explained what to look for in safe, effective designs. Manufacturing improvements emerged from unexpected sources. Female factory workers suggested modifications based on their own laundry experience, better lid designs for easier loading, clearer control markings for intuitive operation, drain positioning that prevented backstrain. These contributions improved usability while demonstrating that women's insights enhanced industrial design. The best machines incorporated wisdom from both engineers and end users. The machine's success created new employment categories that hadn't previously existed. Washing machine demonstrators, typically women, earned good wages explaining operation and maintenance to prospective buyers. Repair services employed female technicians who could discuss problems with customers in relatable terms. Sales positions offered career advancement opportunities previously unavailable to women in retail environments. International adoption spread Fisher's innovation across oceans and cultures. European manufacturers adapted her designs for different electrical standards while maintaining core principles. Asian markets developed smaller models suited to compact living spaces. Each adaptation preserved Fisher's fundamental insight. That gentle mechanical action could replace brutal manual labor. The washing machine became a universal symbol of domestic modernization. Cultural integration proceeded rapidly as the washing machine entered popular consciousness. Advertisements portrayed it as essential to modern family life, while songs and stories referenced the freedom it provided. The phrase labor-saving device entered common usage, primarily describing Fisher's invention. Artists depicted the washing machine as an angel of mercy, liberating women from ancient bondage. The environmental impact initially proved positive, as mechanical washing reduced both water and soap consumption compared to inefficient manual methods. Fisher's precise engineering used exactly the water needed, no more, while efficient agitation maximized cleaning power from minimal detergent. Families discovered their water bills decreasing even as cleanliness improved. The machine demonstrated that technology could enhance both human life and resource conservation. By 1920, washing machine ownership had become standard in urban areas, with rural adoption accelerating as electrical service expanded. Credit programs made machines accessible to working-class families who paid in installments, viewing the expense as investment in family health and opportunity. The question changed from whether to buy a washing machine to which model best suited specific needs. The technology continued evolving through the 1920s and beyond. Automatic timers grew more sophisticated. Spin-dry mechanisms reduced drying time. Temperature controls became more precise. Yet every advancement built upon Fisher's foundational insights about gentle agitation, controlled water flow, and electrical safety. Modern machines, despite decades of refinement, still embody her core design principles. Fisher's legacy extended far beyond her specific invention. Her success encouraged other women to pursue technical careers, to patent their innovations, to challenge assumptions about gender and mechanical aptitude. Technical schools reported increased female enrollment. Patent offices processed growing numbers of applications from women inventors. Fisher had opened a door that would never fully close. The deeper transformation was cultural. The washing machine changed how families conceived of time, labor, and possibility. It demonstrated that technology could serve human needs rather than corporate profits. It proved that thoughtful engineering could enhance life's quality, not just efficiency. Most importantly, It showed that solutions to ancient problems awaited those willing to question why things had always been done certain ways. Today's automatic washing machines would astonish Fisher with their electronic controls and specialized cycles, yet she would recognize her fundamental vision in every load. The perforated drum still turns with calculated gentleness. Water still flows in patterns she designed. Safety systems still protect users from electricity's dangers. Her ghost inhabits every laundry room, a quiet presence ensuring that clothes emerge clean and families remain free. The washing machine stands as testament to how individual determination can reshape society. Fisher saw suffering that others accepted as inevitable and refused to look away. She translated compassion into engineering, sympathy into mathematics, understanding into mechanical reality. Her machine didn't just clean clothes, it cleaned away centuries of accumulated exhaustion, creating space for human potential to flourish. Modern historians calculate that Fisher's invention returned over 40 billion hours to American families in its first generation alone. Those hours became books read, degrees earned, businesses started, children nurtured, communities strengthened. The washing machine's true product wasn't clean clothes, but time, that most precious resource that no amount of money could previously purchase. As washing machines hum in homes across the world tonight, they sing Fisher's quiet song of liberation. Each cycle repeats her fundamental message that human ingenuity can overcome ancient burdens, that suffering isn't mandatory, that technology properly applied can expand rather than constrain human possibility. The machine that began in one woman's workshop now anchors domestic life globally, proof that the right idea at the right moment can transform civilization. Fisher lived to see her invention become commonplace, to witness the transformation she had initiated. In her later years, she spoke rarely of her achievement, preferring to discuss future possibilities for domestic innovation. She understood that her washing machine was not an end, but a beginning, the first note in a symphony of liberation that would continue playing long after her own quiet rest. The machine's gentle rhythm continues even now, that steady mechanical heartbeat Fisher perfected over a century ago. It reminds us that the most profound revolutions often arrive not with fanfare, but with the quiet determination of someone who simply refused to accept unnecessary suffering. When we trace the path from those bleeding hands bent over washboards to today's automated cycles, we see more than technological progress. We witness how one woman's compassion translated into mathematical precision, how her understanding of water's natural wisdom became gears and drums that would liberate millions. Fisher didn't just build a machine, she built a bridge between grinding necessity and human potential, proving that thoughtful engineering could multiply time itself. That most precious resource, no amount of money could purchase before her innovation made it possible. Consider what those 40 billion recovered hours became. The books written, the degrees earned, the children who knew their mothers as more than exhausted shadows, collapsing into bed each Monday night. Every washing machine running tonight carries forward Fisher's fundamental insight that technology should serve human flourishing, not corporate efficiency alone. Her perforated drum still turns with the same calculated gentleness she discovered watching river stones grow smooth. Her safety systems still stand guard against dangers she conquered through painful trial and error. Her vision still shapes how we imagine domestic life's possibilities. The deeper lesson whispers through every cycle. Innovation doesn't require grand gestures or revolutionary manifestos. Sometimes it needs only someone willing to sit beside a creek, studying water's patient work, then carrying that observation back to a workshop where failure teaches as surely as success. Fisher showed us that the greatest inventions often address the humblest problems, that liberation can arrive in the form of a wooden crate containing motors and gears and hope, assembled with watchmaker's precision. As you drift towards sleep tonight, let the washing machine's distant hum remind you. Somewhere, someone is sketching solutions to problems others accept as permanent, following Fisher's example of patient observation wedded to stubborn optimism. Perhaps tomorrow's breakthrough waits in your own notebook, in your own refusal to accept that things must always remain as they've been. Rest now, knowing that Fisher's quiet revolution continues in every home where mechanical servants handle ancient burdens. where time once stolen by drudgery flows back to families, like water finding its level. Her story proves that one person's determination to ease suffering can echo through generations, that the right idea at the right moment can transform not just how we live, but how we dream of living. May your own dreams tonight be filled with such gentle revolutions, such patient victories over problems that only await someone with the courage to say, there must be a better way. Until tomorrow brings another story of innovation born from compassion, of blueprints drawn by those who see clearly what others overlook. Sleep well. Sleep well in the knowledge that the world's great inventors were once simply people who asked better questions, who listened to problems until solutions revealed themselves. They understood that every transformed life begins with someone willing to imagine it differently. The washing machine hums on through the night. Fisher's lullaby of liberation. Proof that the future has always belonged to those who refuse to accept the past's limitations as tomorrow's certainties.